Hello everyone, welcome and thank you for joining us today. We're excited to introduce you to the new AriesPlus temperature controller, a new solution designed to bring enhanced precision and control to your heating processes. Over the next 30 minutes, we will look at two applications, process and furnace requirements, and how AriesPlus interfaces with them. Taking us through the presentation today, we have Paul Haig. Paul is our product manager at Carbolite and has been with us for 38 years in various technical and engineering roles. He has been instrumental in Carbolite bringing AriesPlus to the market. We also have myself, my name is Chris, and I hold the position of Export Sales Manager here in Hope, and I've been with the business for over 14 years. Over my time here, I've held a number of technical and commercial roles across various sales teams. Today, we'll demonstrate the AriesPlus in two distinct applications. First, we'll look at the ashing of biomass materials according to ISO 18122, highlighting how AriesPlus streamlines laboratory workflows and ensures reliable results. Next, we'll showcase the controller's role in the heat treatment of 3D metallic printed parts, focusing on stress relief, a critical step for ensuring the mechanical integrity and performance of components produced using direct additive manufacturing methods. We're also pleased to announce a new feature of the AriesPlus, remote connection via a computer browser. This allows you to monitor and control your heating applications from anywhere on your network, providing greater flexibility and convenience for your operations. Throughout the webinar, you'll see how AriesPlus delivers improved temperature accuracy, operation efficiency, remote accessibility, and adaptability across various thermal processes. Let's get started by taking a closer look at the applications and the controller's features, and then moving into a live demonstration of the remote connectivity. Let's begin with our first application, ashing of biomass material in accordance with ISO 18122. We have picked one specific standard to highlight. In reality, what we will talk about here can be relevant for all regulated ashing processes. Determining the ash content in biomass is essential for quality control and regulatory compliance in various industries. Processes like this demand superior temperature control, strict adherence to test standard protocols, and reliable data traceability for reporting and analysis. The AriesPlus controller addresses these needs by providing reliable temperature ramping, programmable ashing cycles, and web-based access for real-time monitoring and data logging. These capabilities help laboratories achieve both accuracy and efficiency while maintaining full compliance with regulatory standards. Here we see some key considerations for this type of process. If we look at the furnace initially, it must provide consistent and accurate temperature control to ensure reliable ashing results. The airflow through the furnace has minimum requirement for the effective removal of off gas from the process. High quality thermal insulation is needed to minimize heat losses, and the furnace should also allow for easy and safe loading and unloading of samples for efficient workflow. The temperature controller should be capable of precise ramping and holding at set temperatures, with programmable ashing cycles that can be utilized for different ashing standards. Features like real-time monitoring, remote access, and automatic data logging are essential for traceability and for maintaining comprehensive records. Built-in alarms and safety features help protect both the equipment and the samples. Finally, process parameters such as the correct ashing temperature, duration, and sample preparation must be carefully managed. Thorough documentation of results is vital for both quality control and demonstrating compliance with ISO requirements. Here we can see the method requirements of ISO 18122, and again this is pretty representative of most ashing processes conducted in accordance with a regulated procedure. First, proper sample preparation is essential. The biomass sample should be uniformly sized and dried to a constant mass to ensure the results are accurate and representative. After preparation, a precise portion of the sample is weighed, typically between 1 and 2 grams. The ashing process itself requires a specialist furnace that can reliably maintain the target temperatures. Crucibles used in this process must be inert and capable of withstanding these high temperatures to avoid any interaction with the sample. Once ashing is complete, both the crucible and the residue are cooled in a desiccator to prevent moisture uptake before final weighing. Ash content is then calculated as a percentage of the dry mass using the initial and final weights.
Here we see a cross-section of an ashing furnace where we can explain the key features. So at the rear we have an air inlet where air is drawn into the furnace. It moves along these channels which preheat the air before it enters the chamber. The hot air then flows around the inside of the furnace chamber, guiding smoke and volatiles towards the exhaust. The high airflow provides a constant supply of oxygen to aid combustion, and then finally the exhaust fumes and volatiles are drawn up through a tall chimney and out into an extraction system or through an optional catalytic oxidizer. This is a typical specification for a heating cycle for ashing. It's taken from the biomass ashing standard ISO 18122, and we'll see how this is set up in the AriesPlus controller in the next slide. This is the interface, the touchscreen interface of the AriesPlus controller. It's a 7-inch capacitive touchscreen. To create the program, the user must log in at either supervisor or admin level. Once logged in, we can navigate to the programs list and select the new button. The display prompts for a program name, which the user can type in, containing both text and numerical characters. So these can be very descriptive. And the user can easily edit the program name after the program has been created, should they wish to do so. So once we create the program, you'll see that it automatically navigates to the first segment of the program. And in this demonstration, we're using that biomass ash standard test that we looked at in the previous slide. This starts with a ramp to 250 degrees C with a ramp rate of 5 degrees C. So that is entered in the first segment. Then we press and hold and use a little plus button to enter the next segment, which is a dwell. In this case, for 1 hour. Then we are setting up a guaranteed soak band and a tolerance of 10 degrees C. This is because the standard specifies that the temperature must be at the target temperature plus or minus 5 degrees C for that dwell. Then you'll see the next ramp is to 550 degrees C with a ramp rate of 10 degrees C per minute. Then we enter another dwell, this time for 2 hours. Again, the guaranteed soak band and tolerance of 10, they were already set because it's assumed we wanted to use the same setup as the previous dwell. Then we're going to enter in a step back to 0, and that's the end segment. So there we are, that's the program setup. Now that we have the program, we can run it. So we navigate to the program and press the play button at the top of the screen, and you'll see that the home display changes to show the detail of the program. There's a little green indicator which is next to segment number 1, which shows you the current running segment. Here we see key stages of the biomass ashing process for ISO 18122. On the left, you can see biomass sample materials placed in crucibles, prepared for analysis, ground to a specific size and dried. And on the right, the same crucibles are shown after the heat cycle, containing only the resulting ash. This transformation highlights the effectiveness of the ashing procedure. By following the heat cycle, we remove all the combustible materials, leaving a small amount of mineral ash behind. Accurate preparation, heating and weighing at each stage are essential for reliable ash content determination and compliance with industry standards. Here we're comparing the performance of the AriesPlus temperature controller with a previous generation controller. On the left, the chart shows the heating profile from the previous generation controller, and you'll see a significant temperature overshoot above the set point of 250. This overshoot can compromise process accuracy and consistency and potentially affecting the material properties and outcomes. And on the right, you see the AriesPlus. Notice how closely the actual temperature follows the set point profile throughout the heat cycle. The controller maintains precise control, minimizing deviations and ensuring the process remains well within the required limits for optimal results. These charts clearly demonstrate the superior control stability and responsiveness of the AriesPlus temperature controller, providing confidence in achieving repeatable, high-quality thermal processes. This is the graphical user interface of the AriesPlus controller, highlighting its convenient data logging and download features. The AriesPlus interface allows the user to easily access logged temperature versus time data from any heat cycle. Downloading this data is straightforward. If you're working directly at the panel, you can save the log files to a USB stick mounted in the control panel. Alternatively, if you're connected remotely via a browser, the data can be downloaded directly to your computer's Downloads folder. These flexible options make it simple to review, share, and archive processed records and support the traceability and compliance with quality standards that users are likely to require. We'll show you the AriesPlus data logging screen viewed via a remote browser, which shows both the set point in orange and the actual temperature in red. The large blue dot is highlighting the mouse pointer, and as the pointer's moved, a pop-up appears and shows the time and temperature for that position on the chart. We can switch off the set point line so we can be sure that we are interrogating just the actual temperature. And now you can see the chart zooming in and out. This is achieved by using a mouse with a wheel and simply rotating the wheel forwards and backwards. And you see the indication of temperature along the dwell periods, which is well within the tolerances required by the standard.
Okay, on to our second application, the heat treatment of 3D metallic printed parts for stress relief. Additive manufacturing processes, such as 3D printing of metal components, often introduce internal stresses into components, which can compromise mechanical properties and long-term reliability. The main challenges in this process include achieving a uniform heating volume, maintaining precise temperature control, and ensuring that the procedure is reproducible for consistent results. With the AriesPlus temperature controller, you benefit from enhanced accuracy, the ability to program custom heating profiles, and the convenience of remote monitoring and control. These features help ensure that your heat treatment process delivers optimal outcomes for your 3D printed components. As we did earlier, let's look at the key considerations. Firstly, the furnace must provide uniform temperature distribution to ensure that every part is treated consistently. If required, the furnace should have the capability of a controlled atmosphere to prevent oxidation or contamination of parts. Reliable insulation and high quality atmosphere containment are also essential to maintain process integrity. Next, the temperature controller needs to deliver precise temperature control and stability throughout the process. It should allow for programmable heating and cooling profiles to tailor the stress relief cycle to your specific materials. Real-time monitoring, remote access, and robust data logging are important for traceability and quality assurance, while integrated safety features such as over-temperature protection and alarms help safeguard both your equipment and your process. Finally, process parameters, including the stress relief temperature, soak time, ramp rates, and cooling protocol, must be optimized based on the material and geometry of your printed parts. With these considerations in mind, you can achieve consistent, reliable stress relief results for your 3D metallic printed components.
Here we see the equipment setup used for stress relieving 3D metallic printed parts. This is the Carbolite CWF furnace paired with an optional A105 metallic retort and the advanced inert gas package. This combination is ideal for precise heat treatment of additively manufactured components. The CWF furnace provides reliable and uniform heating, while the metallic retort creates a controlled environment inside the chamber. And with the advanced inert gas package, we can purge the retort atmosphere to achieve low oxygen levels, ensuring the parts are protected from oxidation during the stress relief process. Together, these features deliver the temperature control, atmosphere purity, and process stability required for high-quality heat treatment of 3D printed metal parts. We can add an optional cascade thermocouple to the retort and the control system. This is the thermocouple entering the retort. This setup lets the AriesPlus controller adjust the heating based on actual retort conditions, improving temperature uniformity and process accuracy. It's especially useful for applications needing tight temperature control, like stress relieving of 3D printed parts or precise analysis. Here we have two key electrical safety features: an earth connection, which protects against electrical faults, and a proximity switch, which ensures that the retort is correctly placed in the furnace. These features keep the equipment and operators safe and ensure compliance with safety standards. The table here shows how inert gas purging reduces oxygen in a furnace retort. Each full volume change cuts the oxygen by a factor of 10, quickly lowering the levels with each purge, crucial for oxidation sensitive processes. The table displays the drop in oxygen percent and parts per million as the purge continues. With proper gas flow from back to front, the retort atmosphere becomes highly inert, protecting the components and ensuring heat treatment quality. The inert gas package, along with the retort, allows nitrogen flow rates from 2 to 27 litres per minute to suit different process needs. The advanced version features an automatic solenoid valve, so gas flow can be controlled by the AriesPlus program without manual input. 7 flow scales for different gases are included and can be easily installed by the user with no need to specify the gas type when ordering the equipment. Here we have two key features that contribute to temperature uniformity within the retort chamber: the preheated gas inlet pipe and the thermally insulated door plug. You'll see the dotted line showing the preheated gas inlet pipe, which ensures that any incoming process or protective gases enter the chamber at a temperature close to that of the furnace atmosphere. This minimizes cold spots and prevents thermal disturbances, helping to maintain stable and uniform temperature profiles throughout the retort. Similarly, the thermally insulated door plug acts as a barrier against heat loss at the door, further supporting consistent temperatures and reducing the risk of localized cooling that could affect the process. Together, these design elements play a crucial role in achieving reliable and repeatable heat treatment results, especially for applications sensitive to temperature variation. Complementing this, the AriesPlus temperature controller provides excellent control stability, allowing precise management of temperature set points and ramp rates. Its advanced algorithms and responsive feedback ensure that the desired thermal conditions are maintained consistently over time, contributing to the overall quality and reproducibility of your heat treatment process. When you order the advanced inert gas package, you have the option to specify either a program segment output or a temperature alarm for gas flow. This slide shows the program edit screen of the AriesPlus with the program segment event output feature enabled. For each segment of the heat treatment program, you can easily set the gas flow to be either on or off, giving you precise and automated control over the process atmosphere throughout the cycle.
Here we're showing some typical materials that would undergo this type of process. As you can see, the temperature range is very wide, and traditionally a number of different controller configurations would be required to give stable temperature control over such a wide range. With the AriesPlus, we can achieve this out the box with our advanced algorithms and 7 sets of PID control terms. For the next section of this session, we're going to take a look at the AriesPlus connectivity features and how that appears on a computer browser and a mobile device.
So here we see the AriesPlus controller on the product, and if I press this information button, I can scroll down and see the IP address. And we have a computer with a browser, the computer's on the same network. So if I type in the IP address that we see on the AriesPlus screen, you'll see it connects immediately, and you're seeing the same screen. I also have a mobile phone here that's on the same network. So again, if I type in the same IP address, and press go, we see the AriesPlus on that mobile phone as well. So any browser on the same network we'll see. So if I set a set point on the actual controller, you'll see the two remotely connected connections will see that set point immediately as well. So it's very instantaneous. If I make changes on the controller, you see those changes come through on the browser connections pretty instantly. So I will go ahead and create a program on the browser. So let me do that. This happens to have a touchscreen as well, this computer, so I need to log in at supervisor level. So please forget this password. And it offers to save it. I'm not going to save it. So let me navigate to the program screen, and if I go back to the folder list, you'll see there's a new button. I press new. I can enter a name for the program. And it takes me, as you saw in our demonstration earlier, to the first segment. So I'll repeat what we were doing earlier on. So 250 degrees C, a ramp rate of 5 degrees C per minute. It calculates the time. That's based on the current ambient temperature, because we're starting from ambient. And then I press and hold, I get the little plus key to add in a segment. I'll make it a dwell. We will go for 1 hour. And press the little tick symbol to enter that. Then I'll just add in another segment. I'll make it quick. I'll just step back down to 0 so we're not waiting too long for me to show you the demo. So there we see the program, and what's important to know is then if we go to the controller on the product, if I navigate to the programs, you'll see that program is there. So there's no transfer required. The browser is connected to the controller. So when I'm creating that program, I am creating it on the AriesPlus controller, even though it's a remote connection. And of course, if I navigate to programs on the mobile phone view as well, there we are, same program. It automatically opens the program you've most recently viewed or edited. Then you'll see there's a run button here on the actual controller, and on the browser view there's no run button. So we're not allowing you to start the heating process remotely because of safety concerns. So you need to start the program at the actual product. So I'll start the program. And you'll see we get the same display, same on the phone as well. There we are, program running. Connecting the AriesPlus controller to an Ethernet network, you gain the ability to access and interact with the controller remotely using a standard web browser. This means you can monitor and adjust settings from any computer or compatible device within your facility, as long as it's connected to the same network as the controller. This remote access capability offers greater flexibility and convenience, allowing you to supervise processes, review data, make adjustments without having to be physically present at the controller. So we will proceed to a live demonstration and see how these features work in practice. For safety, the AriesPlus remote interface does not allow heating to be started. This ensures that heating operations can only be initiated locally at the controller, protecting both users and equipment. AriesPlus instructional videos are now available to watch on the Carbolite YouTube channel. There's a playlist for these so you can easily find them. Currently there are 8 videos covering the topics listed here, and we will continue to add more to build up a comprehensive library of instructions.
Okay, so we just have a quick question and answer section. So we'll just run through these one by one. I'll ask the questions and Paul can give us some answers.
Yeah, sure.
So number 1, does the AriesPlus have the function of skipping any step in the program?
Currently, no, it doesn't have that function. I guess the good news is that because this is a Carbolite development, that is a feature we could add if we decide that there's enough demand for it. But currently, no, can't do that.
Okay. Number 2, in the slide that shows the before and after image of the biomass samples, has the metal tray changed colour?
Yes, it has. So if you look back at the slideshow, you'll see it's changed to quite a distinct blue colour. The tray's made out of Inconel, and that material will change colour with temperature. So it's an indication it's been to a certain temperature. And I think a good point is that the colour is very even, so it shows that the uniformity of the furnace is good. So yes, it's changed colour.
Very good. Next question's around the process, really. So most ashing customers hold the furnace at a temperature and load and unload hot. This is fast turnaround of samples. Does this not meet the standard?
Yeah, it very definitely does not meet the standard. I think the danger of adding samples to a hot furnace is that the burning will happen very vigorously, and it could lose some ash content out of the crucibles. So I think the purpose of the standard having this slow ramp rate from ambient is to try and drive off the volatiles slowly so that you don't get such vigorous burning. So no, doesn't meet the standard.
Not this specific standard, at least. And
No.
I would add that it is a fairly common practice to see furnaces being used like this, but it depends on the requirements for the process, really. So if the standard demands a slow ramp, as we showed in the content here, that's what should be followed. But if it's not a regulated process that's covered by a regulated standard, then it can be open to interpretation. So not the specific standard, but it's not unusual, I would say. Number 4, can the user lock the screen via user level security functions?
No, there's different levels for login. So as you switch on, you're at operator level, and currently you can set a set point and run a program. But no, we don't have a function to lock out all of the functionality. But again, that is something that we could add to our enhancement list. Maybe if there's enough demand, we could develop it.
What format is the exported data log file?
That is a CSV format. CSV stands for comma separated variable file. So it's a very simple format, and most spreadsheet programs could import that type of file.
Does the remote view facility allow for remote emergency shutdown?
No, it doesn't. Again, if there's demand for that, that's something we could develop. But no, currently you can't start or stop the heating by the remote access.
Can the remote user set up multiple web browser windows to view more than one furnace at a time?
Yes, you can. So you could have many. If you've got many AriesPlus controllers on your network, you could have a web browser tab for each of those.
For stainless steel sample heat treatment at high temperatures up to 1200 degrees, are there some general recommendations when inert gas purging should be used?
I think this is very material dependent. So if a material is going to start to oxidize at a specific temperature, then clearly you would want to introduce the inert atmosphere before that temperature or achieve the inert atmosphere. So I think it would have to depend on the different material types. I think if a user has an inquiry, we could definitely discover the answers for that.
This one's kind of linked to a previous one. How many remote connections can you have?
So I think, yeah, maybe subtly different to the other one in that if you've got one Aries controller on your network and you've got multiple devices, laptops, mobiles, then you can have many devices connected to that one AriesPlus controller for monitoring.
Okay. Can you remotely stop a program or turn the set point down?
No, I think we had a very similar question.
Yep.
So no, currently not.
Okay. In the video that showed a program being created, I saw an import button. Can you explain what that is used for?
Yes. So there's a corresponding export button as well. So if you create a program on the controller, you could then export that either to your USB stick at the controller, or if you're connected remotely, you could download it through a browser, and then you could import that into another temperature controller. So if you had many furnaces of the same type, you could very simply share a program across all of those.
Okay, and finally, is Ethernet included in the AriesPlus controller or an extra option?
It's very definitely included. So yeah, we see it as a key feature of the AriesPlus. So yes, there'll be if you order a product with AriesPlus, there'll be an Ethernet port connection on the back.
And that concludes today's session. So from Paul and myself, thank you for your attention and participation. We'd be pleased to receive your questions directly, and you can see our email addresses on screen now. Thank you and goodbye.